Hi, today I'm gonna solve an interesting problem, which is problem 2131, the longest palindrome that can be formed by concatenating two letter words. So we are given an array of words, and these words are actually two lowercase letters. So we want to create the longest palindrome. Using it, we don't have to return the palindrome, and probably we can form different results therefore, but we want to find the longest one, and we can concatenate those strings in any order to form the longest palindrome, and we can select each element at most once, they're saying. Now we have to return the length, and if we can't form a palindrome, we would return 0. And they're reminding us what a palindrome is. So a palindrome is a string that reads the same forward and backward. So if this ABBA is a palindrome, BAAB is a palindrome, AAAA is a palindrome, but ABAB is not a palindrome. So let's have a look at the examples. We are given here LC, CL, and GG, and we can put GG in the middle and LC and CL on the extremities to form a palindrome. So we will return a length of 6. And let's take an example here. We have these strings, two-letter strings. We can classify them into two types of strings. We have the first type here, and these are two letters, let's call them normal two letters. So let's say here these are normal two letters, and we have these, the other part, which is already a palindrome. So these are palindromes by themselves. And I'm gonna base my solution accordingly. So I will use hash sets. This problem seems to be solvable by hash sets, and we'll come to this in a bit. And these are already palindromes. And I'm gonna create two hash sets, one for the normal two letters and one for those that are already palindromes. And the reason I'm doing that is that I wanna stick the normal two letters at the extremities. So I would take all possible combinations at the extremities and then add those that I know are already palindromes in the middle. Because let's take this example and see what it might lead to. I'm gonna take AB and I'm gonna search for its matching, which is BA, and I'm gonna put it here, and then I'm gonna take CD and search for its matching. I'm gonna put it here, so facing it. EF doesn't have a matching thing, so we're gonna leave it. And here, let's go and take GG. I can put them at the extremities, and then I'm left with GG again and HH, which I have to choose one of because they are not palindromes with each other. So if I put HH at the extremity or another GG at the extremity, my palindrome is ruined. Whereas if I put it at the middle, my palindrome is still there. My palindrome is still valid. And therefore, I'm gonna start by putting the normal two-letter combinations at the extremities. That's the reasoning that I'm thinking of. And then move to put those that are already palindromes in the middle. Because, again, if I put these in the middle, I will have GG facing GG, and then it's either GG or HH in the middle, and I would have a valid palindrome. That's how I can form the longest palindrome here. I will start by declaring hash maps, and the reason I'm gonna use hash maps instead of lists is that these aren't indexed by numbers. I have a key and I wanna find what matches it, and therefore it's easier to use hash maps. I can search them faster. Searching a hash set or a hash map for a certain key is O of 1, whereas searching a list for that would be O of n. So let's declare these two hash maps, hash map, and we'll start with a string, and I'm gonna count the occurrences. Like in the example that we saw here, we had AB once, but what if we had two ABs? I'm gonna count the occurrences, and therefore I'm gonna map each key to each string key to an integer. So we'll call it string count, and it's a new hash map. And I'm gonna also do another one for those which are already palindromes, and I'm gonna call them doubles. So this is called double count, and again here I have a new hash map, and I'm gonna iterate over the words. So I'm gonna have a for each loop here, and I'm gonna take each word in words, and I will check here if this classifies as a normal string or a double already palindrome string. I won't be doing more than that. So if word.char at 0 is not equal to word.char at 1, so if the characters are different, I will add to string count. Otherwise, if the characters are the same, I will add to double count. So here I would put in string count the key and take its value and increase it by 1. So that would be string count dot put word, and string count, I'm gonna get the value. So I'm gonna get word and increase it by 1. Yet, what if I'm putting this key for the first time, and therefore this get word doesn't exist? I'm gonna use, instead of get or default, and the default would be 0. So if I don't find the key, I would have 0 and increase it by 1. That would result in putting the word and 1 facing it, 1 as its value. The same would apply to double count. So double count, I would put the word, and I will use get or default word 0. So again, if the value is there, I'm increasing it by 1. If the value is not there, I'm putting 0 and then increasing it by 1, and therefore I'm saying the count is 1. I will use a counter to count the length. We can call this length instead of count, but I think this name is pretty straightforward. I will count at the beginning the non-double entries, the normal strings that I have that aren't already palindromes. So use non-double entries, and then use those that are already palindromic entries. Let's start. For the non-double entries, I will have a for loop, and I will iterate over the entries there. So I will take every entry, which is a string integer, and I'll call it entry. And I'm gonna take every entry therefore in string count, which I'll use as an entry set. That's how we iterate over keys, every key in a hash map. And I'm gonna take the value, which is entry.get value, and I'm gonna keep something here. Now, initially, I won't have values that are 0, but at some point I'm manipulating this map, and I'm decreasing values, and therefore I might arrive at values which are zeros. For example, if I took AB, which counts as 1, and then I found the matching string, which is BA, which also counts as 1, I'm gonna cancel them, because when I go to check BA, I don't wanna count it twice. Therefore, I will decrease the values for those keys, and they might be zeros. So I will check if it is 0, and we'll see what to do here. And that's the reason that I check the value before the key. And then I will take the key, and I'll use entry.getKey for that. Now I'm gonna search for the reverse. So if I have AB, I wanna search for BA, and I therefore need to reverse my key. So I will create a string that will memorize the reverse key, and I will therefore use a function called reverse string for that key, and I will fill reverse string in a bit. Let's assume that we have reverse string working correctly at this point. Now, if this reverse key isn't there, then I can continue. I have nothing to count. So if string count doesn't contain reverse key, so I will check if it contains key reverse key, and if it doesn't contain it, I will continue. So I will go to the next key, I will go to the next step in my for each loop. Otherwise, I will get the value for this reverse key from the map. So I will get reverse value equals string count dot get reverse key, and therefore now I have the key and its value, and I have the reverse key and its value, and I want the minimum of these two. So I will have min value, it's equal to math.min value reverse value. And for that, let's say we have another example here, AB, AB, BA, BA, BA. I will have 2 occurrences of AB and 3 occurrences of BA. Now that means I have to match 2 ABs to 2 BAs. The third one will stay unused, and therefore I'm bound by the minimum occurrence of these two. That's why I'm using here min value, which is the minimum of value and reverse value, and each one of those has 2 characters, and every time I find in the match, I'm matching AB, which is 2 characters, to BA, which is also 2 characters. That's 4 characters. So I'm gonna go here to count and increase its value by 4 times the min value. Again, let's say I have AB. My palindrome will look like this: AB, BA, and then I'm gonna add to it AB, BA. So these are 2 occurrences of each, so 1, 1, 2, and each one is 4 characters. Therefore, I'm gonna take the min value and multiply it by 4. Now there's one important thing to do here, and it's skipping these keys. So when it comes to reverse key, I'm gonna put in it 0. So when I reach that reversed key while iterating here in this for each loop, I will find 0, and that will take me to this point, which is if my value is 0, that means these were already used, and I can continue. And it doesn't matter if we had like 2 strings facing 3 strings. After all, these 2 were used, and therefore I can't use them anymore. This one won't find a match. I can safely put the 0 here. Now we're done with checking the normal palindromes, or the normal strings that aren't already palindromes. And now we'll move to strings that are already palindromes, which we're gonna put in the middle. So I'm gonna also use a for each here, map.entry, and I have a string mapped to an integer, and I'm taking the entries this time from double count, which I'm using as an entry set, and I have my key, which is entry.getKey, and I have my value, which is entry.getValue. Now here it's not very straightforward. Like I can have, let's say, GG, and these are occurring 4 times, and then I have HH occurring 3 times. Now let's say I started with HH instead of GG. I will be putting HH facing HH, and then I would put this one in the middle, and then I would go to putting GGs, which occur an even number of times. And this is not a palindrome. So I will work just with even numbers. I will try to work with even numbers, and then if I'm left with an odd number, I will add one of it. So let's say I started with HH or GG, it doesn't matter. And I'm just taking the even occurrences, and I still have one HH left. I can put it in the middle. So I will start with the even occurrences. I will only take the even number that I have, and I'll see what to do with what I'm left with. So if my value is divisible by 2, I would increase my count by value times 2, because each one has 2 characters. Otherwise, if my value isn't divisible by 2, I'm gonna take only, let's say here, the 3 entries. I'm gonna take only an even number of these entries, which is 2. So it's count plus value times 2. That took the 3 of them, and I'm gonna remove the third one, the odd one, and therefore I'm gonna remove 2. And this will leave me with 1 key, therefore. So it's double count dot put. Now this can be improved a bit. I can do another thing. Instead of putting double count and with a key of 1, let's say I had many odd occurrences. So I had 3 of these and 5 of these. And my palindrome is like this, and then I had HH, and another 2. I crossed these 2, and I crossed these 2. I can't use them anymore. Regardless of the leftovers, I can only stick one of them in the middle. So I can go to the middle and put here either HH or GG. I can't put all of them. So it's enough, therefore, to have a boolean instead of this count, and let's call it leftovers. So leftovers equals true, and I'll declare a boolean here. So boolean leftovers, which is equal to false initially. So I need to know if I have a leftover at the end of my for loop. If I have a leftover, I will add 2 to my length, to my count. If I don't have a leftover, then I'll go as I am. If leftovers is true, I will increase my count by 2. And at the end, I can return count. Now we still have that function which we mentioned earlier. We need to write it, which is called reverse key, and there are many ways to achieve this. This is not the core of our problem, but a pretty straightforward way to do it is to take these characters and swap them. So I'm gonna take word for my function here, and I'm gonna change them into a car array, which is a new, which is of length 2, and cars 0 would be word.car at 1, and cars 1 is word.car at 0. So I'm just changing their order, and I'm gonna return a new string from that. Let's check if we have some typos, some things. Yeah, here I wrote string count.entry. It should be entry set. And here I wrote string count with an uppercase S. And here by mistake, I used string instead of int, so this is int. Now let's run it on all these. So these are our example test cases, and let's submit it. And we got a reasonable result. This is 86.6% in the top 86.6%, and it's very memory efficient. Now, if we look at it, I'm passing through every word here, and let's say n is the number of words. So I'm taking every word and iterating over it once. So this is O of n. This is O of n in time. It's also O of n in space, because for every word I'm storing it. This is linear. And then I'm iterating over the non-double entries, and I'm checking it once or probably twice, because I might return to a key that I already used here if the value is 0, but I'm continuing. That's also linear. That's O of n in time, but it's not requiring additional space. We already used that. And the same applies for here, for the palindromic entries. It's O of n in time, and there's no more space here. And this one is pretty straightforward. It's O of 1, and therefore my overall complexity is O of n time and O of n space.